had to find an issue on the telephony service itself, because this will be a post-exploitation issue that I could use to elevate privileges. But first, I had to find an issue on the telephony service. So that was the only I was getting when looking at Windows 7, so I started to focus on the telephony service. So I decided to use there is another tool called Process Monitor. It allows you to monitor all system activity on the Windows operating system. And it allows you to filter by many options. You can filter by process ID to display activity to a specific process, by process name, by path of the object that is being accessed, etc. You have a lot of options. This is also a very powerful tool. And you can monitor at the same time registry access, file access, network access. So what I did was set a filter to monitor only the telephony service and run the tool. And after running the tool, I have to interact in some way to the service, so the service will perform some action that will be captured by the tool. So what I did was stopping and starting the service, and you can see there in the background the tool is capturing activity. So I stopped the service, then I started again, and a lot of activities was being captured. So when looking at the capture, there were a lot of things. So I started to look around, and there was something that got my attention. That was one registry key that I haven't seen before. It's a registry key on HKey local machine key, and the sub key is called tracing/tappy SRB. I don't know if you can see it there. So I went to registry editor to look at this registry key, and I thought about checking permissions on the key. And when I checked the permission, I found a surprise there. I found that the local service, network service, and user's account had a special permission. So I went to see what were those special permissions, and I found out that all these accounts could set value, has the permission of set value in this registry key. So this is another issue, because any user can set any value in this registry key that is then read by a privileged process, such as the telephony service. So I think this was a way to maybe exploiting something and then elevate the privileges with the previous issue. So I started to look around at the registry values, also at the registry subkeys, and I could see you can see here very similar names to processes in Windows. So I thought it was a functionality that was used by many processes in Windows. I didn't know what it was about. I was just playing with the tools. So then I started to look at the values of the subkeys, and I found one interesting value called file directory that has a data value of directory, Windows directory. So I look at the directory and it was empty. You can see there is nothing there. Then I continue looking at the values, and I found another more interesting value that was almost self-describing. The values named enable file tracing. And it was a tracing, remember, tracing subkey. So I said, okay, let's set this value to 1 to see what happened. So I set the value to 1. And in the background, process monitor was still running. So I set the value to 1 and returned to see on process monitor if something was happening. And I couldn't find something interesting. Here at the end you can see a file being created in the directory that was specified in the registry. So when I saw this, I started to think that it was exploitable. Maybe the guys that know about Windows local exploitation know how to exploit it already. So I could get a file created in any directory I want. So it was clearly an issue because any user could do that, could change that registry key. You can see there the file that was created, is tapi srb log. So after this, I started to research more what was this tracing functionality. I noticed that it was a functionality used by some services and processes to save information related with the bug, with errors. I don't know, maybe Microsoft used this information for customer support, I don't know. But basically, in that file that is created, is basically saved debug information and error information. So the way to exploit it is pretty simple. Name pipe, you remember one of the APIs used for impersonation I mentioned at the beginning is called impersonate name pipe client. What you can do is build a simple program that creates a name pipe, listen on the pipe and wait for connections. When it gets a connection, it will impersonate the process that is connecting to the pipe. So I saw the issue was very easy to exploit, but I have to confirm if the process will try to access the pipe. So I set in the file directory value / localhost / pipe / x, which will be a name pipe. And after setting the value, I went to process monitor, and I found that the telephony service was trying to access the name pipe. You can see there, it is trying to access the name pipe. So this was clearly exploitable and pretty easy to exploit. Just the only need for an attacker to exploit this is to be able to impersonate. If you can impersonate, then you can elevate first privileges to network service account, which is the TAPI service account, and from the TAPI service account you can access the other process that is running under the system account, because the process is handled with duplicate handle privileges. So basically you can go from any user with impersonation privileges to local system account. But changing the registry value for the telephony service will be a two-stage attack. So I decided to look at the other registry keys, and I found one familiar for me, which is IPH-LP-SBC, which reminded me to the IP helper service. So I went to Process Explorer trying to see if there was the same name as the IP helper. So I looked for the IP helper and I found it. You can see there the IP helper service is hosted in a SBC host process, and the process runs under the system account. So this is the best candidate for exploitation. I only need to write a value to the subkey of this service, putting a name pipe there, and they wait for the connection of this service and impersonate the system account and elevate privileges. You can see there I changed the value, enable file tracing, and then on process monitor, you can see here the file is being created after I changed the value when I enabled the tracing functionality. When doing a more in-depth research, I started to debug a little, and I found out that the processes that use this tracing functionality, they will be monitoring all the time for the registry. So if there is any change to the registry key, they will read it instantly. There is a special API used to monitor changes on registry, and they use it. So the exploit is pretty simple. What you have to do is just set a name pipe, create it, listen on it, change the registry value to the name pipe, enable file tracing, and you get the impersonation token from the system account and elevate privileges. I will show you an exploit now. I run netcat locally, and then I have accessing an Internet Information Service 7.5, which I have a .NET command shell there. I can run any command, and you can see the version is 6.1, is Windows 2008 release 2, and you can see the web application, the worker process of Internet Information Services is running under this special account called default app pool that was introduced on Windows 2000 release 2. Microsoft decided to change that the services, the web application on Internet Information Services don't run anymore by default under the network service account. So now by default they run under this special account, which has the same privileges as the network service account. It can impersonate, which is cool. So I have uploaded this command shell to the server. Then I also uploaded the exploit. The exploit is called chimichurri. So I put the path of the exploit, the remote IP, and the port number. I run the exploit, and I get a reverse shell on my host, and you can see here is a reverse shell running under the system account. So it's pretty easy to exploit. You just need to be able to upload some stuff to some Internet Information Server, and you can root the system. Let's see some code. Well, this exploit is called chimichurri, which is an Argentinian sauce used for churrasco. It was an idea of Federico Kirschman, San Federico, for the nice name. So basically, this exploit, what it does is creating the pipe. You can see here the name of the pipe with the file name that is created by the service when tracing functionality is enabled. So we set this value on the registry value, and then enable file tracing, and we get this file, the name pipe, try to be accessed. So here the name pipe is created. Here we can listen on the pipe, and when we get the connection, we impersonate, and with the impersonation we open the thread token and we run a reverse shell. The trigger of the vulnerability is here. This is the trigger of the vulnerability. So we set the tracing file tracing name to this value, and then we enable file tracing, and that's it. It's a pretty simple exploit. So after finding this issue, I decided to continue looking at the telephony service, because it was very easy to find these issues, and I saw there will be more easy to find. So I found that with the dialer application, which you can dial and call by using the modem, you can interact with the telephony service. It uses the service to make the telephone connection, to handle the modem, etc. So I ran the dialer application while monitoring the activity with Process Monitor, and a lot of activity was captured.